Hey there, science fans. Have you ever stopped to think about all the amazing things happening inside your body right now? Trillions of tiny cells are hard at work, keeping you alive and kicking. And guess what? These cells are always on the move. Understanding how things move around inside cells is super important. It's like understanding traffic patterns in a busy city. We need to know how nutrients get delivered, waste gets removed, and messages travel throughout the cell. So put on your scientist hats and let's dive into the fascinating world of cellular movement. We're going to learn about three key processes: diffusion, osmosis, and active transport. Get ready for some serious cellular action. First up, we've got diffusion. Picture this. You're baking cookies and the delicious aroma of warm chocolate chips fills your kitchen. That's diffusion in action. The scent molecules are spreading out, moving from a high concentration, near the oven, to a low concentration, the rest of your kitchen. In cells, diffusion works the same way. Particles are always jiggling and bumping around, and they naturally move from areas where they're crowded to areas where there's more space. This is how important things like oxygen and nutrients get into our cells. Think of it like this. Imagine a crowded room full of people. If you open the door, people will naturally start to spread out into the empty space. That's diffusion. It's all about evening out the concentration. Now let's talk about osmosis. Osmosis is a special kind of diffusion, but instead of cookies or people, we're talking about water molecules. Water is essential for life, and it's constantly moving across cell membranes to keep things balanced. Imagine you have a container divided by a semi-permeable membrane. This membrane is like a screen door. It lets water molecules through, but not larger molecules. If you put salty water on one side and plain water on the other, something cool happens. Water molecules will move from the side with more water, less salt, to the side with less water, more salt. This movement continues until the concentration of water is equal on both sides. That's osmosis. So far, we've seen how particles move from high to low concentration. But what if a cell needs to move something in the opposite direction? That's where active transport comes in. Active transport is like swimming upstream. It takes energy. Cells use special proteins called pumps to move molecules against the concentration gradient from low to high concentration. Think of it like a pump pushing water uphill. It takes effort, but it gets the job done. Active transport is essential for many important processes like muscle contraction and nerve impulse transmission. So there you have it: diffusion, osmosis, and active transport. These three processes are like the choreographers of the cell, keeping everything moving and grooving in perfect harmony.